welcome to a new episode of Silly Motor Engineering. Today we properly start the work on the car. Now, if you remember last time, I left you with a bit of a cliffhanger. I said we'd be designing and bolt. But before we get into that, let's just go over a few things. You see, when you're designing a car, you're supposed to start from the most outside part and work yourself in. Also, it's what I'm told. Don't take my word on that.
The scope of my engineering genius literally knows no bounds.
So, following that logic, I would have to start by designing this bolt, and then the suspension, and then work slowly myself into a magnificent race car like this one. I mentioned an interesting word there, suspension. What does it actually mean? Now, most people, by which I mean the kind of person who thinks a car is just some kind of sofa with wheels, seems to think that the suspension is just the springs and dampers. It's the bouncy bits. The things that makes potholes slightly less murderous. But actually, it's much more than that. The suspension is the unsung hero of driving. It doesn't just make the ride comfier while you're sipping your soy milk latte. Yes, I am looking at you, basic Western white girls. No, its actual job, the whole reason it exists, is to keep the wheels on the bloody ground. Which, call me old-fashioned, is rather important if you want to steer, brake, or not explode in a fireball of insurance paperwork. Because let's face it, without the wheels on the ground, you are not driving anymore. You're flying quite badly. So I made this little diagram so you understand what I'm on about. Imagine you're looking at the car from the front, right? This will be your wheel. This little part here that connects the wheel to, well, the car. It's called the wheel upright. And this is going to be a huge headache. But we're going to see about it later. And then, well, there's some kind of connection towards the chassis. This represents the chassis. And then you've got, of course, your coilovers. Now, this is conventional suspension. Most cars have this. And actually, I encourage you to open the boot of your car and you will see the attachment points for your coilovers. But we're not doing a conventional car, are we? There exists another system of suspension very similar to this one, called the double wishbone. It looks more or less like this. You've got, same as before, you've got your tyre, you have your wheel upright. However, you have things called wishbones. What are wishbones? This is a wishbone.
That's a knife.
Now, how does that work? This will connect like so to the upright and then to the chassis. Let me draw that for you. You will have, instead of one wishbone or a standard bar like you would have in something like a Citroën 2CV, well, it's a bit different and more complicated, you will have one wishbone like so and another one like so. And of course, thickness like this. Our coilover goes somewhere like this. It goes in between our wishbones. Now, I'm not going to get into the details on why this type of suspension is better. Let's just say it makes the handling better because I don't want to get into details, and also because I don't know. However, just keep in mind that most sports cars today and for a very long time have had this system of suspension. Now, before we move into race car suspension, I just want to open a little bit of engineering culture and history and show you the greatest suspension system ever fitted to an automobile. Funny thing is, it's barely used today and it used to be the norm for a very special brand in my heart. Yes, this is correct, you have guessed it. It is the Citroën hydro-pneumatic suspension.
Pas mal, non? C'est français.
Now, I apologize for my appalling drawing. Right, the hydropneumatic suspension. We're talking about the best suspension system ever bolted to a car. One that delivers comfort so smooth, it makes sandpaper feel like silk. Stability that could shame an Exocet cruise missile. Save the life of a war hero and his wife. And a handling that, get this, destroyed sports cars. Yes, folks, I am talking about the Citroën Xantia, a car designed for beige shirt-wearing boomers that drive to the boulangerie to enjoy a cheeky pain au chocolat, and yet it still holds, to this very day, the record for the moose test. That's the test where you have to yank the steering wheel like a lunatic to avoid an elk, and most cars just give up and slide off to Valhalla. But not the Xantia. Oh no, it absolutely dusted modern supercars. Even the Porsche 911 GT3, a Porsche beaten by something with a suspension that looks like it was made in a submarine using pressurized duck fat. The system was so mind-bendingly good, in fact, that Rolls-Royce and Mercedes, yes, the Germans, licensed it. Because even they had to admit that the French had done something clever, which, let's be honest, is actually a given in motoring and industry. Jay Leno, one of the greatest car collectors and biggest, let's say, motoring influencers, actually said Germany was the birthplace of the car, but France was the nursery. So to all the I don't want to be French crowd that we're having lately, yeah, you lot clutching to your BMW keys like they're rosary beads, I suggest you write a thank you card to Paul Magès. That's the mad genius who invented Citroën hydropneumatic suspension. Also dig out an apology form and send it to General de Gaulle, because not only was he once saved in a Citroën DS with the same system, but he also tried to warn you about the current state of Europe, and you didn't listen. But I digress. Now, like I said, race cars today don't use either the wonderful hydropneumatic suspension or conventional suspension. They use something a little more exotic. They use something called the Pushrod or the Pullrod system, which actually aren't that different from what we saw before of the double wishbone suspension. You still have your two wishbones connected to the wheel upright and to the chassis. You still have your tyre and your wheel upright. You still have your coilover. However, in the case of pushrod, when the wheel is forced up, the green line, a push rod, a rod that you push, will be pushed upwards. Here we have a joint connected to the chassis, allowing a pivot, pushing on our coilover. And this is how the suspension is done. The pull rod is quite the same, except it's different. As you see, here the rod is not pushing, but it's pulling. Indeed, if my wheel goes up, the rod will be pulled this way. These are the two that are used today in Formula 1, in Formula 2, in any open-seater and, most of the time, also closed-seater categories, as you can see about.
Right, welcome to the world of push and pull rod suspension. These systems are the reason why your favorite race car doesn't handle like a canoe full of bricks. Now on paper, both the system do more or less the same thing. They take in the bumps from the road, feed it through a rod, either push or pull, to the chassis with some very clever springs, do all the damping out so it makes the ride slightly less shattering. I say slightly because they're extremely rigid. Now the push rod is a sensible older brother. It's brilliant at absorbing bumps, it's easy to set up, easy to build, easy to understand. But like all sensible older brothers, it comes with compromises. For example, first of all, a higher center of gravity because of course you have more mass at the top, all your springs and dampers, and can make the inside packaging a bit of a nightmare if you're not careful. Then comes the pull rod. It's sleek, it's slow, it's the supermodel of suspension. But of course, there comes drawbacks. It's more complicated to maintain, it's more annoying, it's more difficult to design. It allows plenty of great trickery at the back, especially in modern Formula 1 cars, but is it really worth it? both systems are complicated. Both systems demand quite a lot of attention, and if that attention is not given to them, the car just ends up handling like a drunken spider. So, which one is better? It depends. A few weeks ago, I asked you on Instagram if you would prefer the Pushrod or the Pullrod, and, like Moth attracted to a flamingly complex suspension diagram, you all voted for the Pullrod. I commend you for that. And the thing is,
I love democracy.
which is why I've chosen the Pushrod. Right, now we know what we're talking about. I apologize if this video is looking a bit too much like a class about suspension, but now we all know what we're talking about and I've actually clarified things in my head. But let's get back to what we were saying at the beginning. We have to start from the exterior, so the bolt. We are then going to have other things. Of course, there's what we've already talked about, the wheel up front, but there are other things in here. Let me just show something to you. This. It's taking a while. This will be the center lug nut. That, of course, will attach my tires and prevent me from flying off. This piece is not wheel upright. This piece is called the hub. Where does it go? Let's do a bit more drawing, shall we? So here I've got my tire, as we said before, tire, and we are not going to bother drawing different things. We of course have to have a bolt. And what you've noticed is this bolt has this shape, so well, of course the wheel remains centered. It's very important. So we've got a bolt like so. It's not very true to size, but it will do for the explanation. It's a bit too big. Looks like a big funnel. This bolt then goes into our hub. After the bolt, of course, we have the wheel hub, which presents itself a bit like this. So here, of course, to make a connection with the bolt. Here, as you can see, we again have an angle to accommodate the wheel and to keep it very centered and nicely done. But then, what about this piece that you see right here? Now, there are a few roles of this, what we call in French, collerette. The first one, and the most crucial one, is to fit what we call pegs. Now, in this case, the pegs are a separate piece, but I think in the design I will be doing, the pegs will be integrated. Now, you have to picture this. If I'm doing a front view of this, you will have, of course, this little front part here, and then our collerette with 8 to 12 of these pegs coming out, which will then enter the wheel and allow it to rotate with our entire wheel system. The other role of this little collerette, something that you'd see a king in the Renaissance wear, is to fit your brake disc. Lastly, on the wheel hub, you have to think about where you're going to be putting your bearings.
There's something oddly calming about drawing. Not the Instagram kind, where someone paints a watercolor of a croissant and gets a million likes. I'm talking about proper drawing, engineering parts, bearings, brackets, bushings, things that one day will become real. I've never been particularly good at it. My lines wobble, my first attempts usually look like a chicken's fever dream. But it brings me peace. The sort of peace you get from doing something with your hands, like woodworking or tinkering on an old motorcycle, or laying a bit of roofing under the sun with a hammer and a hangover. It's not easy, but it's just hard enough to hold your attention. Like the world saying, here, focus on this for a bit. The existential dread certain ways. And here's the thing, this isn't new, this is ancient. Craft, work, running after something until your lungs are full of fire. We were made for this, not spreadsheets, not PowerPoints. Craft. Aristotle said it best. The hand is the tool of tools. And while he didn't have to wrestle with a janky CNC or constantly make his SolidWorks model crash, there's something fundamentally human about putting a pencil to paper, glass of whiskey and a cigar nearby, and sketching a bracket of caliper lost in the middle of nowhere in the Italian countryside. And let's be honest, the better your sketch, the easier it is to model in CAD later, and then CNC. A physical object as stunted as a scribble in a bar. That's magic. That's engineering. Right, then here we are, the final result. It's actually, believe it or not, quite similar to my relationship with women in the sense that it is absolutely appalling. So what you will notice, however, is what we talked about for the lug nut. It has this wedge. It has the fillet that doesn't go all the way in, and with a little counter wedge here to force it into our hub. And we have all the views here with most of the dimensions. Now, let me just make a point here. This is not my final product in the sense that this is to help me to do the 3D CAD modeling later. Then moving on to the hub, this is a magnificent front view. Here will be the pegs that we talked about that will enter the wheel and allow the wheel to rotate. And here, of course, our mounting places for our brake rotors. Now, if I take a profile view, it'll look more or less like this. Now, you'll notice a little ridge here. I think it's a ridge, I don't know how to speak English. This will prevent my bearings from going any further than that, but I'm not 100% sure about this. These dimensions here depend on the bearings that I've chosen, and this of course depends on the previously designed lug nuts. And then lastly, a rear view, which is this spot here with this curvature. I've got right here, although this drawing's appalling as you can see here, apparently I don't know how to use a compass. I have all the dimensions I need, and it's pretty clear what's next. And on this, I'm afraid it's time to end. If you've managed to go through this entire charade without falling asleep, congratulations. I will see you next time very, very soon on the Wheel Upright. Goodbye.